Hello class, welcome to lesson 10.3, which is all about operations with radical expressions. By the end of this lesson, you should be able to add and subtract radical expressions, and you should be able to multiply radical expressions. Okay, so let's take a look at our first example. We just want to add these radicals together and have it written in the simplest form possible. So if we do that, we have a 3 square root of 2 minus 5 square root of 2 plus 4 square root of 2. You might look at that and say that's a lot of numbers. But let's think of it kind of like our x squareds. If I gave you this, you would look at it and you'd say, oh, they're all x squareds. I do 3 minus 5, which is negative 2, plus 4, which gives me a positive 2. And you'd say the answer was positive 2x squared, because you're just combining like terms. The same thing goes for those square roots. Those square roots are the same thing. You can treat them like the same thing because they're all the square root of 2. So you can say this is actually 2 square root of 2, and you are done. Don't overthink this. If we look at this next one, I see I have 4 square roots of 3, 3 square roots of 7. I have negative 6 square roots of 3. Sometimes I like to box around so that way I remember to look for positives and negatives. Okay. So if I look, I boxed my square root of 3's in the same color. So I have a positive 4 square root of 3's and a negative 2 square root of 3. So 4 minus, or negative 6 square root of 3. So if I do 4 minus 6, I get negative 2 square roots of 3 left. And then I have a positive 3 and a positive 3, or plus 6 square root of 7. And I am done. Now I can't combine this because, let's say square root of 3 is x. That means square root of 7 is like x squared. You don't combine those. So we leave them as is. Let's look at our next one. So I have 15 square roots of 3. I have a negative 11 square root of 3. If I combine those, I have 4 square root of 3. Then I have a negative 14 square root of 5 and a positive 6 square root of 5. That works out to be a negative 8 square roots of 5. And I am done. Right, looking at the last one, I have 6 square root of 11, positive 2 square roots of 11, and oh look, a negative 9 square root of 11. So I do 6 plus 2 minus 9. So that's a negative 1 square root of 11. Or you can just write negative square root of 11. And that is your final answer. Alright, why don't you go ahead and try one on your own. Good luck. Hopefully for this one you said the answer was 5 square root of 13. If you have questions, let me know. Try one more. Hopefully for this one you said 6 square root of 2 plus 3 square root of 3. Again, if you have questions, ask either myself or a friend. Example 2. We are going to combine what we learned yesterday with what we are doing today. So I have 4 square root of 54, but I see that 54 and I know that that can be broken up into 6 times 9. And I know the square root of 9 is a nice number. It's a 3. So on the outside, I have 12 square root of 6. And then I have this plus 2. 24 can be broken up into 6 times 4. And if I do the square root of 4, that's a 2 that I can pull out. And I'm left with 4 square root of 6. So now I have 12 square root of 6 plus 4 square root of 6, or 16 square roots of 6. Alright, let's try another one. We have 3 square root of 45. I see 45, I think 9 times 5, or 3 times 3 times square root of 5, which gives me that 9 square root of 5. Square root of 20, that one breaks up into 4 times 5, or 2 square root of 5. And then I have minus 245. I wouldn't know this one necessarily right off the top of my head, but I see that it ends in a 5, and the rest of my square roots are 5. So I'm going to do 245 divided by 5 to see what I can multiply 5 by in order to get there. If I do 5 times 49, I end up at 245. So I have minus, the square root of 49 is 7. Okay, so I carry that down. Now I have a positive 9, positive 2, negative 7. So I have 11. So 9 plus 2 gives me 11. Minus 7 is 4. And then I bring down my square root of 5. If you have questions, please be sure to reach out for some help. Go ahead and simplify this expression. Hopefully you ended up with 61 square root of 5. If you have questions, be sure to reach out for some help. Alright, example 3. Now we're going to practice multiplying. Notice that we have two numbers on the outside, so we multiply those together. And then we have our square roots, and we multiply those together. So I'm left with 14 times the square root of 18. And I know 18 can be rewritten as 9 times 2. I can pull a 3 out. 14 times 3 gives me 42 square roots of 2. So that is as simplified as I can go. Alright, this time I have 3 terms, and I'm going to be using my distributive property. Okay, so I have 3 times 4, so I have 12 times the square root of 2 times 3. Carry down my plus sign. Then I have 3 times 6, which is 18. And then square root of 2 times square root of 2, or 2 times 2 inside. Now if I continue to simplify, I have 12 square root of 6 plus 18, and then that's square root of 4, or just the square root of 4, right, is 2. So I have 12 square root of 6 plus 36 as my final answer. If you have questions, please be sure to reach out for some help or rewatch this part of the video. Go ahead and try this one on your own. Good luck. Hopefully you got 30 square root of 6 for this first one. Try one more. And hopefully for this one you got 16 square root of 3 plus 20. If you have questions, go back, rewatch the video, look at your book, talk to me. So many options. Pick one of them. Alright, now we're going to talk about the area of a rhombus can be found using the equation A equals 1/2 diameter 1 times diameter 2. Where or D1 and D2, where D1 and D2 are the lengths of the diagonals. Sorry, I shouldn't have said diameter. That's circles. What is the area of the rhombus at the right? So our first diagonal is represented by this expression. So 8 square root of 5 minus 3 square root of 6. And my second diagonal is 6 square root of 5 minus 2 square root of 3. So if I, didn't mean to move that. Okay, now I'm going to try to move things. So I have area equals 1/2. I'm going to deal with that 1/2 later. And I see that I have 2 terms times 2 terms. I'm going to use my FOIL method. So if I multiply my first terms, I have 8 square root of 5 times 6 square root of 5. So 8 square root of 5 times 6 square root of 5, which is 8 times 6, which is 48, times, and then 5 times 5 is 25. The square root of 25 is just 5. Or 48 times 5 gives me 240. So I'm going to have 1/2 times 240. My outer terms are 8 square root of 5 times negative 2 square root of 3. So I have negative 16 square root of 15. Square root of 15 is as simplified down as it can get. I'm going to have minus 16 square root of 15. My inner terms are negative 3 square root of 6 times 6 square root of 5, which gives me negative 18 square roots of 30. 30, I think, okay, what are some numbers that go into 30? I have 2 and 15. Neither of those break up. I have 3 and 10. Neither of those numbers break up. And I have 6 and 5. neither of those numbers break up. So I'm going to leave that as is. I'm going to say minus 18 square root of 30. Then my last term is negative 3 square root of 6 times negative 2 square roots of 3. Negative 3 times negative 2 gives me a positive 6. And then I have square root of 18, which is 6 times, my square root of 18 is 9 times 2. So I can pull a square root of 9 is 3. I can pull a 3 out, square root of 2, or 18 square root of 2. And it's positive. Now, if I move all of this down, notice I still have the times 1/2, so I have to multiply everything by 1/2. So area equals half of 240 is 120. Half of negative 16 square root of 15 is negative 8 square root of 15. Half of negative 18 square root of 30 is negative 9 square root of 30. Half of positive 18 square root of 2 is 9 square roots of 2. So my area for this rhombus is represented by this number, this expression. All right, why don't you go ahead and try to find the area of this rectangle. Good luck. Hopefully you got 14 square root of 42 minus 34 square root of 2 units squared. If you have questions, please be sure to reach out for some help. Have a wonderful evening.